All right, so let's continue to work on developing this concept of the standard normal curve, the z-score values, and what all it means to statistics, probability, and that kind of stuff. There we go. Like, I don't know why it's not showing. Okay, so like if I'm a step girl, so show me 3 or 4 steps, and I got it. All right, so what we do is we draw the normal curve and shade what we need to, like if it's left, right, less than, if it's greater than, if it's in between. And then depending on if it's left, right, or between, we do a couple of things. So if it's left, we just look up the table or like use the calculator. If it's right, whatever we get from the table or the calculator, we have to do 1 minus, because the table and the calculator are programmed only for less than, only for the left values. And so if we want the right values, then we need to do 1 minus so that we get the complement, we get the opposite. If it's between two z values, then we can type, the first one in our calculator, look up the first one, or look up the second one, or do the calculator for the second one, and then we subtract those two values. All right, so those are kind of the rules we need to remember as we go through these sample problems. All right, so I want to remind you of the rule. It's right here, and then we're going to do one that's to the left. And so the problem is just find the area under the standard normal curve. I said that really funny. To the left of negative 0.99. All right, so negative 0.9, negative 0.91611 as we get on the chart. So that's right there. Okay, if we want to type it in our calculator, remember you do the second bars. Okay, remember this is just a blanketed number. We just picked a huge, that'd be if we had 10,000 people, things in our sample. And then we type the negative 1.99 from right there, and we get the same answer. 8 makes that a 1, so that's why it's a tiny bit off. All right, let's do one that's to the right. So the problem's right here. Find the area under the normal curve, 1.06. 1.06. All right, so these are the negative numbers. Here we are, 1.02, 6. So 0.8554. 0.8554. Okay, and that's what we get right there. But the rule is if it's to the right, you do 1 minus. Okay, and that's really our answer. Now here is the great thing about the calculator. If you type it in, notice you can do a couple of things. Okay, we want 1.06. So I'm going to show you something. Second bars. Okay, 10, 1, 3, 1.06. All right, so I got is it negative? Okay, anyway. Let me, I don't remember the number now. Yeah, 1.06. Okay. Look at, let me type. Right, there we are. Okay, and so I got 0.144. You cannot have a negative. But you can change it. If you want to prevent that negative, remember everything's symmetrical. If you want to prevent the negative, that's why they did this backwards. And they did it backwards because it was right. So they pushed the second bars, and then they went to CDF, and then did 1.06, comma, then the blanketed 10,000, Okay, and so when it's flip-flop, because it's to the right, then you get rid of the negative sign. That's why. All right. What if it's in between, like two values? All right, we can look up negative 1.5. Let's do that. Negative 1.5, 0.668. Here. And then 1.25, positive. 1.2, 0, 1, 2. 8, 9, 4, 4. So that was this. And then because it's between two values, you subtract. And so that means in between those two z-scores, 82.76% is the probability. That's what the probability is. All right, if you want to use the calculator, no worries. It's going to figure out that subtraction for you. And so, excuse me, so you put the lower bound, which is the smallest number, then you put that upper bound, which is the biggest number, and it will automatically pop out. You don't have to subtract anything. The thing over here was that we wanted to the right, and so the smaller number, when something is to the right, we're going to put like the number we're looking for here, and then that just generic 10,000. If we want to the left, then we would put the negative, because we want everything less than the number that we're looking for. The number that we're looking for was that 0.99, the negative. And so I guess like the hardest or the most confusing part is that like when do you put negative, when do you put positive, when it's not between two values, which is why you may understand the chart better, and that's totally fine. I want to be able to give you more than one way to do these problems. All right, so we learned the empirical rule. That was this guy. 1, 2, 3, 3. 68% of the data happens here. 95% of the data happens here. 99.7% of the data happens there. That was the empirical rule. And so, and then I talked about how, you know, if it's greater than 2 standard deviations or less than, like, if it's, so that's here. If it's anything over here, it's pretty unusual. If it's greater than 3, so over here, where it's just 0.5%, the probability is there, it's very unusual. All right, also recall, like we did a problem earlier where we looked it up on the chart and it was one value. When we looked it up, when we did it in the calculator, it was another. They were uber close together. Like the rounding was just off a little. And so just keep that in mind. Excuse me. As you do this, as we get into the more complex problems, if you're doing the problem and you're, whatever, a few hundreds off from what I get, it's fine. All right, so let's do problem. The survey indicates that people use their cell phone on average of 1.5 years. All right, so the mean. The standard deviation is 0.25 year. That's sigma. The cellular phone user is selected at random. So one particular person is selected at random. Find the probability. Remember, when we find probability, we're really finding area. That the user will use their phone for less than a year before they buy a new one. And then it tells us normal. All right, so. Gosh, I'm so sorry. All right. You can do a couple of things we're going to do. Okay. So to do it by hand, all right, the first thing we need to do is find the z-score. And so what they did was, it's the value, so 1 right there, then minus mu, it's right there, divided by the standard deviation. Standard deviation is here. Okay, and then it pops out -2. So that means that it is yeah, so then we need to go on the chart, -2. Right here. And so when we look it up on the chart, that's what we get. Or, I suggest, it's significantly easier if we, it will do all of that for you. Right, so this was less than a year, okay? So we just need the smallest boundary. Then, this is that 1. Okay, this there. Then we have the 1.5. That's right here, 1.5. And we have 0.25. 0.25. All right, so how can you remember what order it goes in on the calculator? All right, so normal. Oops, sorry, that should be this way. All right, it goes lower bound. So like if it's, oh, I'll help you. Okay, upper bound. And then it goes mu, and then the standard deviation. Okay, so how do you know on these upper and lowers, like which is which? Sometimes if it's left, right. All right, so if it's left, like something is less than, then you're going to do -10,000, and then the number, and then mu there. If it's right, you're going to do the number, 10,000, mu, and then the standard deviation. Right, so that those notes should help you out on like what and when you type in. Oh, if it's between, then we're going to do the lowest number. We'll do the high number. Then we'll have mu, the mean, and we'll have standard deviation. Okay, so that should really help you out. In fact, I'm going to write that down so that I don't forget it. Actually, I'm going to take a picture of it. It's easier to take a picture sometimes. All right, I want to pause before we get into this, and then stop, and I'll do the next problem in the next video. All right, bye guys.